Okay. Let's take a look at a couple more. Let's take a look at problem D. In problem D, we'll start the same idea. We'll start on the x-axis. We've got an angle of 541. Sorry. So where is that? Well, first of all, if you're not sure where that is, it's bigger than 360. So at the very least, you've gone around the circle once. So the question is, where do you keep going after that? So let's take the 541, and we've gone around the circle at least once. So let's subtract the 360 and see where that would mean we would keep going. So let's take the 541 and subtract 360, and that gets us 181 degrees. So that means I've already gone the circle. I took out the 360. What do I still need to do? I need to go another 181 degrees, which means, well, 180 would land me here. 181 would land me a little bit past that. So 541 degrees means I went in a full circle, that's the 360, and then also went another 181 past that, which landed me over here. Again, notice I went counterclockwise because my angle was positive. Now they want, again, the same angle that's going to end there, but they want a positive angle. What's the smallest angle? Well, notice this angle they want a circle to get. Well, the smallest angle would be, don't go in the circle then. Just go straight to the angle. Well, we found out how do you get straight to that angle is that 181. Don't go around the circle. So the least positive coterminal angle that ends in the same spot is just doing without the circle, doing just the 181 degrees. And that's it. Let's do one last one, starting again with the x-axis, and this time we have the same angle we've just dealt with, 541, but this time negative, and that does change a lot now that we've got a negative angle, because that means at the very least we're going to be going clockwise, so negative 541 degrees. Well, let's see. If we go ahead and go around the circle once, let's see, going around the circle once, let's add that circle back in, and that would leave us that we still have to go in reverse by, let's see, another 181 degrees. So to get my final angle, I still need to keep on going. 180 would be to the second quadrant line, but getting the 81 would be going a little bit past that. So that puts me over here in quadrant 2. Again, remember, even though I'm going clockwise, I still number going counterclockwise. Sometimes they'll ask you that. And this is my final angle of negative 541 degrees. So remember, to do the negative 541 degrees, you have to do the 360 going in a full circle. Then, to get the rest of it, you have to do another 181, which is a little bit more than 180. Now the question is, how do I get the same angle, so a coterminal angle that is positive? Well, that means start at your x-axis, and the quickest way to get a positive angle is just to go in counterclockwise and land where I started, looking for this red angle here. Well, what would that be? Well, notice from here to here is just the negative 181. So what would the red angle be? Well, together they'd have to be 360 degrees. So we'd take the 360 degrees and subtract the 181. And let's see what would be there is a 179. And then that's going to be our angle that lands us in the second quadrant. That's the smallest that we can use. And it does end at the same spot here, exactly in the second quadrant. It's the same exact angle as the 179 degrees. And we're done. Okay, last problem. Let's take a look. So we're going to draw a blank angle here to kind of see what's going on. they are giving us a 45-degree angle, which when starting on the x-axis, it's positive, which means you're going to be going counterclockwise of 45 degrees, which is halfway between the 90-degree angle. Now they want us to come up with an expression that generates any coterminal angle possible. Well, coterminal means that it would end at the same spot. Well, kind of think about it this way. We'd go the 45 and then we'd keep on going around the circle. That would be one way to do it. And you could go around the circle not just once, but you could go around it. Let's see, you could go around it multiple times. So we could go to the 45, come around back, and go around as many times as we wanted. So to kind of write this out, that's how you get coterminal angles, is that you'd say, well, I'm going to start out with my original angle, 45 degrees. And then what I want to say is that I can add or subtract going around the circle. A circle. Because technically I could do the same thing in reverse. I could start at the x-axis and go around the circle in reverse as well, taking away a circle. And I could do it once, or I could do it multiple times. And I'd still land there. So always starting out with the 45 degrees and either adding or subtracting a circle is kind of the idea. But we're just going to leave it as, we always say add. And then what we'll do is, in order to actually take care of both addition and subtraction of circles, we'll just use a number n times what? Well, this will make sense, is times, well, what are we taking away and adding? Circles. Well, circles have what in degrees? They have 360 degrees. So what this is saying is take your 45 degrees and multiply by a number n of circles. You can either use a positive n or a negative n. It means you're going to either add circles or take away circles. N will be the number of circles you're either adding or taking away, based on if it's positive or negative. So our final answer is our coterminal angles are going to look like 45 degrees plus n times 360 degrees. And n actually can be positive or negative. If it's positive, we're going to go around the circles counterclockwise. If it's negative, it means we'll go in reverse, meaning we're going clockwise. And that's it. Last problem here. We've got a windmill makes 90 revolutions per minute. How many revolutions per second does it make? So right now we've got revolutions per minute. And the way that it's written is out in words, so it's a little bit confusing. So shorthand, it would look like this, revolutions per minute. I think a better way of looking at it even, though, is as a fraction, as 90 revolutions. And this is a shorthand that this 90 revolutions is for every 1 minute. And we can do what we were doing before for conversions, is we're trying to take minutes and turn them into seconds. Well, I'm going to use the fact of how many minutes are in a second. Well, how many seconds are in a minute? There are 60 seconds in 1 minute. Well, I want to cancel out the minutes, so in order to get rid of them, one has to be on bottom and one has to be on top. So I'm going to put the 1 minute over here on top, so that there's one on the top and one on the bottom so that they cancel out. And then that means the other piece, the 60 seconds, will go on the bottom. So what this now does is gives us a way to figure out the value, which is we'll have the 90 revolutions times 1. Well, 90 times 1 will just be 90 revolutions. Because remember, the minutes canceled out. And then look what else we have on the bottom. We have 1 times 60 seconds. Well, 1 times 60 would be 60, so over 60, and that's in seconds. But they want them in revolutions per just 1 second, which means we just need to go one step further, just one step, and actually go ahead and do this division. So the question becomes, what is 90 divided by 60? Well, 90 divided by 60 is 1.5, and that's again in revolutions. Revolutions per, and we said we did the division, so this is now per just second. 1.5 revolutions per second is what our equivalent value is by doing a conversion here. And we're all done.